Welcome to this Python tutorial. In the previous tutorials, we already implemented a multiple linear regression model that we fitted to the training set. But when we take a step back, do you think it's actually the optimal model that we can make with the data set that we have here? You know, because when we built this model, we actually used all the independent variables. But what if among these independent variables, there are some that are highly statistically significant, that is, have great impact on the dependent variable profit, and some that are not statistically significant at all. That means that if we removed these non-statistically significant variables from the model, well, we would still get some amazing predictions. So the goal in this tutorial is to actually find a team, an optimal team of independent variables, so that each independent variable of the team has great impact on the dependent variable profit. That is, each independent variable of the team is a powerful predictor that is highly statistically significant and definitely has an effect on the dependent variable profit. And this effect can be positive, that is, for an increase of 1 unit of the independent variable, the profit will increase, or it can be negative, that is, for an increase of 1 unit of the independent variable, the profit will decrease. And so we're going to divide this final step of building this optimal model using backward elimination into 3 tutorials. In this first tutorial that we are having right now, I'm going to walk you through the backward elimination preparation, because in Python we actually need to prepare something specific, which you will see in this tutorial. Then in the second tutorial we are going to start backward elimination together without completing it up to the end. That means that at the end of the second tutorial you'll get a homework, which will consist of completing what we started with backward elimination. So I'm sure you will have no problem, because I'm going to walk you through the introduction of backward elimination so that you can understand everything and have all the tools to complete the homework. And then in the third tutorial, I'll give you the solution of this homework and we will complete together the backward elimination. So I hope you're excited. Let's start right now the backward elimination. So we will, of course, as usual, need a library, which is going to be the stats models API library. Then we'll just need to do a little trick so that backward elimination runs properly. And then we'll be good to go. So let's do it. Let's first import stats models formula.api. And then let's give maybe a shortcut, because this is a long name. So let's give the SM shortcut for a stats model. And now we are almost ready to start backward elimination. We just need to add a column of ones in our matrix of features, our matrix of independent variables. And to understand why, we just need to look back at our multiple linear regression equation, which is here. Y equals b0 plus b1 x1 plus bn xn. Well, you notice in this equation that there is this constant b0, which is not associated to an independent variable x, like there is no x0 here. But actually there is. We can associate an x0 to this constant b0, it's actually x0 equals 1. So that means that if we set x0 equals 1, then our multiple linear regression equation becomes y equals b0 x0 plus b1 x1 plus bn xn. And actually the stats models library that we are about to use right now doesn't take into account this b0 constant. So we will somehow need to add it in our matrix of independent variables, because as you can see, our matrix of features x, which is here, only includes the independent variables like the dummy variables for the state, the R&D spend, admin spend, and marketing spend. There is not this x0 equals 1 anywhere in this matrix of features. And in most library, like the library that we use here to build our linear regression model, it definitely included the fact that there is a constant b0 in the multiple linear regression equation. But that's actually not the case for this stats models library, which we will use to compute the p-values and evaluate the statistical significance of our independent variables. So that's why we need to do something here, and this something is to actually add this column of ones here in our matrix of features. So we will take our matrix of features x here, and we will just add a column of ones here that will correspond to this x0 equals 1 associated to our constant b0. That way our stats models library will understand that the multiple linear regression equation is actually y equals b0 plus b1 x1 plus b2 x2 plus bn xn. So let's do this. It's actually really simple. We will just need one line to do this, and let's do it right now. So since we want to add this column of ones here to our matrix of features x, we will start by taking x here. And then we will use this append function of numpy, which will append this column of ones in our matrix of features x. So let's do this. We are going to call np here, dot, and then append, which is our function. Now let's add some parentheses, and let's press Command and Control plus I to inspect the append function. Okay, so what are our parameters? The first parameter is R for array. So of course this is going to be the array to which we want to add this column of ones, and therefore it's going to be our matrix of features X. So here as a first argument, we'll input R equals X. Okay, and then what is the second argument? The second argument is values. And this time, of course, the values are all the ones that we want to add to X. And as you can see, these values are in the shape of an array. That means that here values is going to be an array. And that's perfect for us because we actually want to add a column of ones as the first column of X. So the array that we're going to input here will be a matrix of 50 lines because as you can see, X has 50 lines and one column. So we need to add a matrix of 50 lines and one column with only one values inside. And there is actually a trick for that. We can do it very quickly. We just need to use another function of NumPy called ones, which will create an array of only one's value inside. So we will need to specify the number of lines of this array and its number of columns. So our second argument is going to be values equals, and then we take our ones function from NumPy. So we add here np dot ones. And then since this function ones returns a matrix of only one values inside, we need to specify the number of lines and the number of columns of this matrix of ones that this function ones returns. And if we look at this ones function in more details by inspecting it, pressing Command and Control plus I, well, we see here in the parameters that the first parameter is this shape. That is the shape of the matrix of ones we want to create. And as you can see, we need to input it this way. We need to input some parentheses with inside the number of lines and the number of columns. So here we will just need to input new parentheses in which we add the number of lines, which is 50, and the number of columns, which is 1. But now we need to do one more thing, because otherwise we will get a data type error. And to prevent this data type error from happening, we just need to convert this array of ones here into the integer type. And to do this, it's very simple. We just need to actually add as type and in parentheses int. And now we just need to add the last argument here, which is axis, because you can use the append function here to add either a line of these values or a column of these values to the matrix here, which is our matrix of features X. And therefore we need to specify if we want to add a column or a line. So if we want to add a line, then it's axis equals 0. And if we want to add a column, then it's axis equals 1. So here we'll just add axis equals 1. And now, I'm sorry guys, there is just one tiny little thing to do before this line is ready to be executed. It's related to the fact that right now we are indeed adding this column of 51s here to our matrix of features X, but we're actually adding it at the end of our matrix of features X. And we would like to have it at the beginning. So according to you, what can we do here? We can use a very simple trick to actually add this column of ones here at the beginning of our matrix of features X. What is the trick? Instead of adding this column of 51s here to our matrix X, what if we added instead our matrix X to this column of 51s here? And so to do this, it's actually real simple. We just need to invert and put it in R this way. And then for values, we input X. So that right now we are adding our matrix of features X to this one column of 51s here. And therefore, this column of 51s here will appear as the first column of our matrix of features X. And now, of course, I'm going to show you that this actually adds this column of ones to our matrix of features X at the beginning of the matrix. So let's go to Variable Explorer here. Let's have a look at X right now. So as you can see, X contains all the independent variables without the first column of ones here. So these are the two dummy variables for state. This is RD spend, this is admin spend, and this is marketing spend. And now, if I select this line and press Command and Control plus Enter to execute, let's now have a look at X, and you will see that now X contains this first column of ones here. And this column corresponds to this X0 equals 1 associated to this constant B0 in the multiple linear regression equation y equals B0 plus B1x1 plus B2x2 plus Bnxn. Okay, so let's press OK. And now, the moment we've all been waiting for. We're going to start backward elimination. But we're just going to take a little break now, and we start doing that in the next tutorial. Until then, enjoy machine learning!